Today we're going to talk about dividing polynomials and the remainder factor theorem. This is a way to divide polynomials. So let's say you have this problem. 382 divided by 5. This 382 is called dividend. The divisor is 5. So if I do 7 times 5, I get 35. Minus 3 is minus 35 minus 35. Bring down the 2. 6 times 5 is 30. The remainder of 2. And this answer we get is called quotient. That has 36 to 30. You could do the same thing with polynomials. So you have this problem. 3x cubed minus 2x squared minus 7 divided by x squared plus 1. So it's over here. So we look at any number that I could multiply this by to get 3x cubed. So if I do 3x cubed over here, 3x times x squared is 3x cubed. Over there. And this 2 times the 3x times 1 is 3x, and the 0, you also have a problem, there's no x, so we put a 0 there. So you get negative 2x squared minus 3x, 7. So then is there any number we could multiply by to get this? So 2 minus 2 will give you negative 2x squared, and this will give you 7 minus 2, 5. Plus 2 there. So this is a remainder. So you could write it in two ways, right? You put a 3x minus 2 plus the 3x minus 5 over x squared minus 1, or x squared plus 1 times 3x minus 2 plus 3x minus 5. So, the division algorithm says if p of x and d of x are polynomials with the d of x is not equal to 0, then there exists a unique polynomial p of x and r of x such that if I divide p of x and dx by dx, we get q of x, which is my quotient, plus the remainder of x divided by the denominator of x, the divisor of x, or the divisor times quotient plus the remainder will give me my polynomial. And the degrees of this is going to be either 0 or going to be less than the degree of x. So let's look at the problem. P of x is 2x fourth minus 3x cubed minus 1, and the d of x is x squared plus x 1. And write the result in this form. So you look to go through all the things, numbers that could cancel out the first term. So 2x squared times x squared give you 2x to the fourth. It cancels out. 2x squared times x give you 2x cubed, and 2x squared minus 1 give you 2x squared. You add them up, you get 5x cubed plus 2x squared. Then you find negative 5x. Multiply, you get negative 5x cubed plus 5x squared minus 5x. You get 7x squared minus 5x. Bring down the 1, negative 1. You multiply by 7, you get 7x squared minus 7x minus 7, and you get the remainder will be negative 12x plus 6. So you put in this term d of x is x squared plus minus 1. Then my q of x, 2x squared minus 5x plus 7, plus my remainder. The remainder theorem says if I divide a polynomial by p of x by the divisor divisor d of x equal is x minus c, then the remainder is p of c. So basically what it's saying is, if I say my divisor is x minus c, if I do the simplification, I will get r of x. Okay? This is called a synthetic division. So when you have something like x minus c, you can use synthetic division, and it looks confusing, but it's really easy. So let's say that you need to use this problem. 3x cubed plus 2x squared minus 4x plus 1 by x minus 2. And we know this is the form of x minus c. Write the result in the form of this and find out what is p of 2. So we write it 3x cubed plus 2x squared minus 4x plus 1 divided by x minus 2. So the only thing we are looking at is the coefficients 3, 2, negative 4, 1. And we want 2. X minus 2, so we're going to bring the 2 down. The first thing you're going to do is bring down the 3, then multiply this by the 3. So 2 times 3 is 6. We'll add them up. So 2 plus 6 is 8. 2 times 8 is 16. We'll add this up. Negative 4 plus 16 is 12. 2 times 12 is 24. Add about 25. So our q of x will be 3 of x squared plus 8x plus 12. And if I was to write it, this is my remainder, so x minus 2 times my qx plus my r of x. The p of 2 is 25 because we said that the p of x is equal to d of x plus q of x plus r of x. And r of x is, in this case, p of 2. The factor theorem says if p is a polynomial, then p of c is 0. And if and only if x minus c is a factor of p of x. So it's saying if a p is a polynomial and the polynomial c is 0, well, x minus that number has to be, if x minus c is a factor of p of x, then this is true. Okay? So knowing the zeros of polynomial and factoring out is the same thing because we know the zeros. So let's look at this. Find a cubic polynomial that has zeros at negative 2, 0, 1, 3. Well, since it needs to have factors at these locations, so we write it as x minus negative 2 for this one, x minus 0, and x minus 3. You are working backwards. These are the, if I was to solve this, I will get this. You work backwards. And you only have to just solve it. X plus 2 times x minus 3, and I rewrote it. Then I fold this to get x squared minus x minus 6. Then multiply by x. You get this. This is one possible solution. Okay? Now p of x is equal to x cubed minus 4x squared minus 7x plus 10. So the p of 1 equals 0 and use this to find all the zeros of p of x. If we could plug in, so you get 1 minus 4 minus 7 plus 10 equals 0. This will give you negative 2, I believe. Or we can use synthetic division. So I have 1, negative 4, negative 7, 10, and we're going to use x minus 1. So bring down the 1. 1 times 1 is 1, so negative 4 plus 1 is negative 3. 1 times negative 3 is negative 3. Negative 7 plus negative 3 is negative 10. 1 times negative 10 is 10. Other way is 0. P of 1 is 0. Then the q of x is squared minus 3x minus 10. You factor the x squared minus 3x minus 10. Since if this is formula, you can use a quadratic formula to solve for x, or you can factor it. You get x minus 1, x minus 5 plus 2. So your zeros are 1, 5, and negative 2. I'm going to use the same thing over here. Um, I would get -2 from this calculation. That's 3.3 about.